After an injury, the body's natural reaction is hemostasis. Next, we have blood vessel wall repair, and then fibrinolysis removes the blood clot. When you fall off a bike and scrape your knee or accidentally cut yourself with a knife, this can damage the thin tissue of the blood vessel. When the blood vessel is torn or ruptured, the blood can escape, and that's when we bleed out, and that's not a good thing. If the body loses too much blood, it can be life-threatening. So therefore, the body has a natural reaction to when we bleed out, and it's called hemostasis. This begins with initial vasoconstriction, which is a vascular spasm. This causes the blood vessels to constrict and tighten up, and this narrows the pathway for the blood to flow through. This diagram shows what a normal blood vessel looks like and what it would look like after vasoconstriction makes it narrow. When this pathway becomes more narrow, less blood can escape. It decreases the blood flow. This is essential because it's kind of like turning off the faucet. If there's less blood flow, the body bleeds out less. The next step after the initial vasoconstriction is platelets attached to the collagen that was exposed in the tissues that were torn in the blood vessel. So the platelets recognize that the collagen is now exposed, because the collagen is usually hidden, and the platelets attach to this site. They stick and attach and form a blood clot. This blood clot stops the bleeding, and it also triggers the release of chemicals. The first chemical is ADP, and this chemical is used to create this adhesion and stickiness. It makes it so that the platelets are more sticky, and it makes sure that the structural support of this clot is more efficient and really sticky and attaches together. The next chemical that is released to reinforce the hemostasis process is serotonin. Serotonin helps with the process of constricting those blood vessels. Serotonin tightens the blood vessel, making it more narrow and decreasing the amount of blood flow. The next chemical that is triggered to release is thromboxane A2. This pretty much kind of supports what the ADP and serotonin are doing, because the thromboxane A2 promotes the stickiness that allows the platelets to attach, and it also promotes the tightening of the blood vessels. This diagram shows the chemicals that contribute to vasoconstriction and adhering the platelets to the blood clot. Once the blood clot is formed, the endothelial cells, which make up the walls of the blood vessel, begin to multiply and go to the site of the injury where the tissue was damaged to start to repair the walls of the blood vessel. Another part that happens is the smooth muscle cells, which are the middle layer of the blood vessel. Those begin to grow and repair the blood vessel. So once the blood clot is removed, the blood can then flow normally as it did before the injury. This is a diagram of the blood vessel showing that the endothelial cells make up the wall and how the smooth muscle cells create the middle layer. Once the blood vessel is repaired, the body no longer needs the temporary blood clot. To remove it, a process called fibrinolysis occurs. This begins with an enzyme called plasmin. The plasmin begins to break down the fibrin threads. Here we see after an injury, the blood is flowing and the initial vasoconstriction starts. Next, we see how the blood clot is formed by platelets. Over here, we see how fibrin holds the blood clot together. Fibrin threads were what were holding the blood clot together. Therefore, once these fibrin threads are dissolved, the blood clot goes away and the blood is able to flow normally as it did before the injury.